Okay, yes, my talk will be about the regulation stuff. Yeah, we at Bundesdruckerei, maybe I introduce my company first. German company, we are doing like the passports, the EID cards for Germany, we're also printing money. And we're doing a lot of other stuff related to ID stuff. We also have this D-Trust and Qualified Trust Center for the EIDAS ecosystem, which is for like qualified signatures and issuing certificates. We are also engaged in the health system, in the infrastructures, in the digital infrastructure. So this is why all the regulatory things that are happening right now regarding post-quantum cryptography are heavily affecting our company. So me and my colleague in this project, we are at the innovation department there. So we are, our main focus is on introducing PQC into our products. And my main focus is how is this with public key infrastructures. So this sets the stage. I'm involved in many standardization bodies. We are doing like proof of concepts, showing how this could work. So, right. So my presentation, yeah, maybe have a little bit, duplicates from the presentations before. But I think, I hope it will be anyway interesting. I think this question, if you looked at the presentation before, you can answer this quite easily correctly. So which one of you is using PQC already day to day? I see 1, 2, 3, 4. Okay. So, right. The answer is basically all of you. If you have WhatsApp, if you have Signal or iMessage, they all adopted already PQC in their message protocols. So there you see this is already rolled out. So you're already using it if you use one of these, for example, applications. And Bas already explained how this is in the web PKI. So he has better numbers than I do now, so I do not go into this deeply. So you can say, okay, we rolled this out. What is the problem? Yeah, of course, because all of these stuff, and even I would say web PKI is kind of a similar issue, are island solutions. So you have a few stakeholders, sometimes only one, with WhatsApp or whatever, who can do whatever he wants with his applications, updates them and introduces them, and everything works. But there are other systems using cryptography who do not work that way. And this is, for example, for the EU, and that's where we are concerned, like the EIDAS system, where we have many, many different stakeholders, from states to companies to end users who all use different kind of software, even very specialized software to exchange cryptographically secured data. We think about like the passports, so travel relevant data which need to be readable by states over the world in the end. So migrating such systems is a kind of different beast. Why the PQC migration is not really advancing right now. Other stuff like protocol ossification are also a reason. So in some protocols, you already have like the ability to just change stuff or do like hybrid or multiple signatures, multiple key exchanges. But question is, since they were not used before, how well do they work right now? So, I mean, examples are like protocol certificate extensions for the version 3 of the X509 standard, which took quite long until they were adopted by most clients. So when you base your cryptography on one of these extensions, then maybe they will not work in the most ways. So, and kind of other thing is also about the PQC state. We have kind of a communication problem, mixed signals. So that adopters are not confident that where they have to move now. So there's still a lot of discussion. There's still a lot of new articles on what is PQC, what kind of algorithms are there. Are they safe? Are they not safe? And this is kind of, on our view, prevents fast and straightforward migration. That is why we really welcome that the EU authorities kind of enforce regulation or want to enforce regulation on this stuff. So it started with a joint statement of the member states that the quantum threat is real. I think it was a couple of years ago. And that the transition shall start now. But this was already, quite, not detailed, just a statement. But in the end, they said that the store now decrypt later attack is an issue. That's why we want to move. But they also mentioned stuff like public key infrastructures, which I already told you are very complex systems. Where we said, okay, signatures in previous talks are not an issue yet, but migrating such systems takes a very long time. So from our experience, this migrating from RSA to ECDSA in such systems took 20 years until after the introduction of an EC algorithms was really broadly implemented in all the relevant systems. So we had the case where we issued an EC root certificate, and we had to, some of our customers could not handle this because some important vendor, big vendor, did not support it yet in their mail servers. That was a problem. So, that's why we also welcome this EU roadmap that was issued, I think, spring this year. They, in this roadmap, they say, okay, milestones. They set milestones for high risk and medium risk use cases. So they set certain dates, which is good in our view. They put the emphasis that they want to see hybrids. I think I will go into this topic later on a little bit more. And yes, they kind of align with other European institutions. So from the different EU countries, how they align the view of these together in one document, which is also kind of good because so you do not have diverging plans for this migration. When you look at the details, there should be a plan by end of 26, implemented by all member states. Okay, what does this mean? In the end, this guideline, this roadmap, which is a kind of a disadvantage here, does not enforce this migration plan. It's just, a good advice. So each member state still has to adapt for themselves and put some law in place or in action that this has to be done. So when it says there needs to be first steps implemented by all member states, we'll see if this will happen for all member states by the end of 26. So, I mean, this is just only a year. So having a migration plan ready, this could be quite challenging. Or the migration plan is not very detailed, or whatever. Or it comes later. Again, this is not enforcing anything, this kind of roadmap. Yeah. So, and by 23, the most critical use cases shall be implemented. So that's software upgrades should be post-quantum resistant, and all high-risk use cases should be transitioned to PQC. I will maybe talk later on what this could mean for companies or government agencies. And by 2035, we should transition medium risk cases. This could be examples, these PKI signature stuff for critical infrastructure. And all of the other use cases that are neither high nor medium risk, they can be adopted later on if it's ready, if the stuff is available. So they are not imposing any timeline there. Okay, some more details on the milestone 1. Milestone 1, make a plan. So first step would be identify stakeholders. Okay, for high-risk use cases, what could be stakeholders there? At least for Germany, there's some kind of catalog which says critis companies, critis agencies, which is critical infrastructure. So it could be energy companies, health industry, of course, which could be critical. This kind of stuff. So, and when you count them and you have a federal system with different, even in Germany with different member states, you get a lot of people who need to move. So this is quite challenging to get them all into one boat. And so that is why it's important to have kind of these talks or this events like these to raise awareness that there needs to be they need to do something, and to enable them to give them the tools to make this migration later on, or even to see that they have an issue. Right. And the second milestone by 2030, I already said, these these critical use cases need to be migrated. And again, what I said before, these kind of many different companies that would be included in this migration step really pose a challenge. So, and this still means that this kind of EU roadmap is adopted by the member state. So you see maybe where the problem lies. This is roadmap. It's there are good a good orientation. They're nice that they put dates there, but for us, it's still kind of our own business when to move forward, because there's no definite regulation in place right now. Okay, that comes the question, do I need to act if there's no regulations that enforces us to? This kind of stuff is taken from the PQC migration handbook that was compiled by TNO in the Netherlands, which is kind of a quite good overview of many different things, and they give a good steps how you can identify where in this kind of class of adapters you are, and when and what you need to move, what you need to do. Okay, basically in this handbook they have 3 classes of adapters. So these urgent adapters, regular ones, and cryptography experts. So, and they have some kind of decision matrix that you can follow to identify in which kind of class you are. I think this is quite a nice tool. You can look at the handbook, it's freely available. It's also referenced by the EU roadmap plan. So it's good when you need to follow this roadmap from the EU. It's also good to have this handbook ready and just check. It's quite easily where you are. Then you can do, when you see what kind of class you're in, you can also do your use case based vulnerability diagnosis. They are asking different questions, and then you can land in green. You don't need to do anything. Yellow, it's not urgent, but you should do something. And high risk would be in red. And this is basically kind of a migration plan. So the actual migration stuff, so the real things when you start touching your infrastructure, is the red boxes there, which is quite small. So many of the steps for the migration can be done in advance. And sometimes you should anyway do them if you want to have a good plan of your infrastructure. I mean, there's stuff like make your crypto inventory. So at least for Germany, the BSI anyway enforces this by some other regulations. Have your responsibilities clear. Who is responsible for which component, and so on and so forth. All this kinds of stuff, which are kind of no regret moves. Yeah, because you should do them anyway if you want to have a good organized infrastructure. Okay, so supply chain dependencies, anyway, risk assessment, and so on. One of the main challenges in this PQC migration, when you follow these steps, is that migration tools that are specific for the PQC are kind of not in a ready state yet. I think that is reflected also by our clients and what we experience also internally in our own processes. When you say, okay, I want to do a crypto inventory, or then people come to us and how should I do it? That's, I think, the same as Bas mentioned before. So a lot of stuff you need to do is raise awareness, give advice what they should look at first in order to tackle this issue. Maybe in 1 year or so, there are maybe tools available who really support this. But right now, I think crypto discovery or tools or something that do this automatically. I have not seen such tools in broad deployment. So this is kind of an issue here. Also, these kind of demands exist, as I mentioned before. So the BSI demands it for the IT Grundschutz regulation, also ISO 20001 certification. But up to date, these kind of regulations can be satisfied with just Excel sheets that are static documents that are set up once and you refer to them and that is fine. But I think when we really want to be crypto agile, then we need some other stuff. And this is still work that needs to be done. And I also see that, there are, at least for smaller companies or something like this, they have a problem that most of these tools are too expensive right now. Like asset management tools of the big ones really cost a lot of money. And for the ones that are like for free or lower prices, with lower pricing, they don't have the features and probably you won't get them for a longer time. So this is kind of a gap here. And this diagram we already seen before, mix around. This is the other thing that I mentioned before, the communication problems, the jungle of the algorithms. I mean, when we look at the middle here, say we see algorithms everyone can agree to. But at least for Europe, when I was talking about European companies, these yellow boxes also have the requirements to use hybrids. And this is kind of a specialty that we need to care about. And this, I mean, we just have the first standards of the post-quantum cryptography algorithms. Hybrid standards are not really yet there, at least partly. There are some available. I can go into details a bit later on. But for example, when you look at this CMS, cryptographic message syntax, for example, for travel documents, ICAO, they are currently disallowed hybrids. So there's also some kind of not matching thing here that needs to be solved in the coming years in order to satisfy all of the regulatory requirements. Come to the hybrids. The inevitable. BSI and ANSI require them. So Reason why? Okay, one thing is missing trust in the mathematics. I think this has been discussed broadly. What I really want to focus on in my talk is this trust on the implementation. The new algorithms are complex, so they will be prone to implementation faults. And we already see in our existing algorithms that they, even after 20 years of implementation experience, we still see faults. I mean, the last really heavy one was the oil leak break, or the oil leak fault in the implementation of one crypto library of an Infineon chip. And this is because this fault was so deeply in the lower level, it affected many other applications, not only YubiKeys, which use this kind of library, but also stuff that we used in our company. So then you have to hassle about and try to fix this stuff or make workarounds or something. And this was an implementation fault in ECDSA. I mean, how long has this been around? So our conclusion as a company who does like many high-risk use cases is that in our view, hybrids are not only for the migration phase, but actually we want them to stay. Not necessarily the PQ traditional combinations, but later maybe also PQ hybrids. Because yes, yeah, we have a good discussion. Yeah, you see, because we have like devices out there which take like have a long lifetime, like these ID cards, 10 years or so, which are also expensive. And if really we have the issue that the root fails in this kind of case, because of such an implementation issue, then we have to like exchange all the ID cards in a short time, which is a resource cost problem for us. But also it's kind of trust issues, and the press will be really bad about. So this might really lose us the whole business in the end. And that is why I think we want to stay on the hybrid path for a longer time. And this PQC migration we see as a way to introduce this kind of mechanism to the infrastructure world, so that we can take advantage of this also in later scenarios or later years. So it doesn't mean that needs to be in all kind of use cases, of course. This is some kind of other discussion. I'm not sure how I'm in time. 15 minutes, okay, good. Okay, just a few words on this stuff, how to hybrid. There are different layers where you can hybridize your infrastructure, which would be the organization layer, like having parallel PKIs, for example, double signing, whatever, which is, of course, a kind of half manual work you have to do there. And I mean, it's even hard for many companies to even have one PKI running and issuing certificates. So doing this twice for every use case, I think it's clear that it's a no-go, for example. The second layer where I can do hybrids is at the protocol layer. In short, every protocol then has their own flavor how to do hybrids, and the issue is that you have friction, because between protocols, if you like look at certificates and TLS, how do like a hybrid in TLS, which uses 2 keys, gets these 2 keys from a certificate. So you need to write some adaptation codes then, and this could be also tricky. That's why we are preferring this crypto layer approach, where you like combine algorithms into algorithms. From the outside, this looks at one algorithm. Inside, they are 2 algorithms. This removes this kind of friction. The disadvantage is you also don't have the flexibility that you could have when you do this at the protocol layer. But in our view, this kind of approach is worth this. Just a few examples, what's already here. So you have at the protocol layer already like multiple signatures in the CMS. You have this ESA catalyst approach in the certificate world. You have this TLS hybrid key exchange, as it's not standardized yet.
Very soon.
Very soon, okay.
Basically, it's what you can use now.
Yeah, okay. I didn't follow it closely, so. Okay, or you, for example, in the VPN world, the V2 additional key exchanges, we have multiple rounds of with different keys. Yeah, they all like do for their own protocols this kind of hybrid approach. So when you look at the crypto layer, you have currently basically also these composites that we are doing at the IETF. Which hopefully also are soon ready. You know, so we are all both engaged in the discussions there, which took a long time. So, and yes, this is other approach, which is kind of the generic composite, or we call this intelligent composed algorithms, which are more flexible combiners instead of the static two-way combiners. Okay. When you there was some kind of interesting proof of concept on this kind of hybridization with Singapore Central Bank, also a monetary authority, and the Bank of France, where they like tested in an email exchange this kind of protocol layer hybrids, how they work. And this is basically shows what I expected, or what we expected in this kind of approach, that when you do this protocol hybridization, then you have a lot of intermediate systems who need to be adapted also, because they all handle the protocols and they all need to understand what the protocol extensions mean, else they like reject them, don't support them, or whatever. So like these, for example, these anti-malware systems who analyze email communication, they also need to be aware that there are additional protocol fields that they need to recognize in order to let the mail through. This kind of stuff would not happen if you use the crypto layer approach. Okay, conclusion. As I said, the roadmap, we have blind spots there. So we have, this is not really enforcing stuff, and it's quite unclear what organizations are really affected by this yet, and what actually, how big is the problem we're facing when we are migrating. So there needs to be a bit more regulations than we have now, at least in the member states. They need to put up the plan, and we need some more effort into the migration tools. And standards, especially for hybrids, because they are not complete, and this will hinder adoption of this PQC cryptography. So, yeah, if you are affected, you should start preparing now. at least do these no regret steps that are issued there. And yeah, thank you.